Hello everyone. Now the new class is going to focus on the quadratic function with key features. So quadratic, as the name suggests, means you can expect a degree of 2. So what exactly is a quadratic function? It's a kind of an equation that will take a mathematical expression and will look like y equals ax square plus bx plus c. So you have now three parameters, A, B, and C. So A is going to control the shape and opening direction in a way. I'm going to illustrate more on the parameter of A. What B will do is it's going to control the horizontal shifting. And what C will do is that it's going to control the vertical shift. So you will literally see when I show you the animation, you will have fun when you get to see these controlling factors in action. You will get to see that the parabola is literally, moving sideways and moving up and down. But before I take you there, it's important to understand the basic, which is in here. Let us take an example. Y equals 1x square plus of minus 4x plus 3. So here what we know is that the value of A is 1, B is minus 4, C is 3. Now, this is the x-axis that you need to be focusing here. Yeah. And this is your y-axis that you need to check. Yeah. So now how should we plot this particular parabola? Okay, so here we have some formulas for your life to get simplified. What is the value for the vertex, right? So I pre-calculated it already and I have got 2 and minus 1. How did I get it? That's what I'll tell you. So for vertex, we have this formula for point x, which you can write as minus b by 2a, and the value of y will be minus b square by 4a plus c. Or in a reverse way, you can just say it's c minus b square by 4a, which is fine. So let us see whether what I calculated is correct or not. So this is my equation, as I told you. So minus b by 2a, which would be minus of minus 4 divided by 2 times a. And that is 4 by 2. And that means it's 2. So yeah, I got 2 here. That's the value for x. Now let's see the value for y. So I get the value of minus 1. Let's see if it's right. Okay, so to calculate the value of y, okay, I have here minus of b is minus 4. Okay, small error. Minus of b square. So yeah, it's minus 4 whole square by 4 times a plus c, which is your 3. So what should you get? 4 fours are 16, minus 16 by 4 plus 3. So you're getting minus 4 plus 3, which is equals minus 1. Cool. So my programming script gave me the right result, which means the calculation is correct. Happy. And I'm getting vertex as 2 comma minus 1. And so now I have the understanding as to how to calculate the vertex. So this is what I wanted to show you guys because we need to know this. And then the next step is to understand how to calculate the y-intercept, this one. How did we get this? So the y-intercept formula is 0, comma, c. And you know the value of c from here. This is 3 here. So I can simply say 0, comma, 3. So here your value of x is then 0 and y is 3. So how do we plot it? So it's a kind of an equation that is, you can say y equals 3, or let's say y minus 3 equals 0. And this is how your this particular thing, the y-intercept, can be plotted. So you can see here your x is 0 and your y is like 3. So you can just plot something like this. Yeah. And we get the y-intercept, which is 0, comma 3. And then we have the next thing, which is called as the axis of symmetry. You can see this is the axis of symmetry here, this particular thing. How did we get axis of symmetry? Interesting question. And I can see that it is essentially being guided by the fundamentals of quadratic equation. So first of all, we have to also calculate the roots. So minus x equals minus b plus minus root over b square minus 4ac by 2a. Okay, so before getting into the axis of symmetry, let me also tell you the roots. I think that would speed up the process. So if you just calculate it, you will get this particular thing and this particular thing. So we are getting this point and this point, but before this plot is being generated, we are actually calculating these values, and then we are going to get this kind of a plot. Okay, now coming into the axis of symmetry. So to get the axis of symmetry, it's again guided by the vertex, and we already got the vertex. So you see the vertex was 2 comma minus 1. We calculated this vertex in order to get this particular line. So in a way, you can recall the entire thing in this fashion, that if you have this particular equation, you first calculate the vertex, then you can go for the axis of symmetry, and then you can go for the roots, and you can also go for the y-intercept. Once you have all these things with you, you get a beautiful plot like this. It's easy, right? Well, it's not that easy. Okay, so I'm going to now take you through the next slide, which I have. Yeah. Okay. Yeah, just a moment. Sorry, guys, I have to take one call. Okay. Yes. Here we are getting this particular thing. This is a plot that I generated using my programming scripts. So what is important for you to understand here is, let us say we have an equation that is parabola, say y equals 0.5x square. So here your b and c doesn't make sense, because those portions, those two terms, that is 0. We are just focusing on y equals ax square in here to understand the effect of a. Okay, this is y equals 1x square, y equals 2x square, and y equals minus 1x square. This looks like a valley. It looks like a U-shaped valley. Essentially, this parabola is opening upward, which means if you look at the value of A, if you just look at the modulus of A or the magnitude or the absolute value of A, you see that if your A is, first thing is that if it's greater than zero, then it's going to obviously open upward. If it's less than zero, it's going to open downward. So for these particular three plots, what we have is A is greater than zero. For this particular plot, we have less than zero. Your A is less than zero for this one. There is another thing which is mod A. Now this value of mod A, if it's very small, like in case of zero point 0.5, you're going to have a very flat kind of a valley, or should I say wider valley. It's not exactly flat, but wider. And now if you kind of manipulate your zero point 0.5 and make it 1, let's say you're increasing the value of A. So more this value of A will increase. So what is going to happen then? From here, you will get something like this and then something even steeper. So the steepness is, going to increase. So your valley starts becoming more steeper. But let us say you have this kind of a situation where your entire story is reversed. The entire narrative changes. So your A becomes less than zero. So obviously your parabola will be now facing downward. And interestingly, in this case, your mod A will not make sense as compared to others because this value is anyway less. So maybe we can compare it with other negative values to see how there it will change. But the fun pattern here is to understand how this A is making sense. So A is controlling the shape. Now I will take you through the animation. This shows that the parabola is opening up and down. You can see also that there is a little bit of effect of the shape. Sometimes it's opening wide, sometimes it's becoming a little steeper, but it's going up and down. This is the effect of A. And now I'll take you through the effect of B and C. Please allow me a minute. Yeah, it is this one. I hope you can see my screen. This is the effect of B, where you see the horizontal shift left and right, and it's dynamic. It's not stationary, so it might take you some time to go through this. Yeah, here it is. So this is the effect of the sea bouncing up and down, and after a long trial and error method, finally I got this. Okay, great. So this animation is giving you that vertical shift up and down. So this is the effect of C, and that's all, folks. Enough for the day, and I'm going to see you soon with the new function, the third type of function. Any guesses? Stay tuned. We're going to cover all the functions, mainly the most commonly used functions. So stay tuned.